Welcome to Homework Lib.
To answer this question, we need to remember a couple of things. First of all, that the mass of the electron is going to be equal to approximately 9.11 times 10 to the minus 31 kilograms, and the mass of protons and the mass of neutrons is going to be comparable. They're not exactly the same, but they are the same for all of the chemical purposes. That is 1.67 times 10 to the 27 kilograms, minus 27 kilograms. So from here we know that the mass of the electron is going to be approximately related by this factor to a single proton or to a single neutron. So that means that we are going to require 1,836 electrons to account for one proton. So in this case, we can say from all of the compounds that we have here, or for all of the atoms to be more precise, in this case, the mass of all the electrons in radon, the mass of all the particles in the nucleus of the beryllium-9 isotope, mass of all the neutrons in carbon-12, and the mass of all the protons in nitrogen-3 minus, the one with the least mass is going to be the mass of all the electrons of radon. Radon contains 86 electrons because its atomic number is 86. So 86 electrons is not enough to account to any single proton. So that is going to be the one with the least mass. Now to compare the other ones, we're going to compare the mass of all the particles in the nucleus of the beryllium isotope. Beryllium is going to be a compound that contains 4 protons plus 5 neutrons. So all of them are the particles that we're going to have in the nucleus, so we have 9. Now we're going to compare it with the mass of all the neutrons in carbon-12. Carbon-12 is going to have 6 protons plus 6 neutrons. And we also need to compare it to the mass of all the protons in nitrogen-3 minus. Nitrogen-3 minus is going to contain 7 protons plus 7 neutrons. Now let's compare the masses of each of them. All of the particles in the nucleus of the beryllium isotope, this is equal to, this would give 11 elemental mass. Let's put it mass of the neutron because they have the same mass. The mass of all the neutrons in carbon-16, we are going to neglect these guys, so this is going to account to 6. And next, the mass of all the protons in neutron-3 minus. In this case, it is equal to 7. So, in ordering terms, the mass of all the neutrons in carbon-12 goes into this position. The mass of all the protons in nitrogen-3 minus goes into this position. And finally, the mass of all the particles in the nucleus of the beryllium isotope would go in this position. So that would be all. Thank you very much and have a good one.